Okay, excuse me. All right, this is week 4's homework questions. I'm going to be doing questions 2, 4, 10, and 13. So first question is find the domain of the function natural log of x squared minus 4. All right, so what we need everything inside the natural log or the log to be greater than 0, not greater than or equal to, but greater than 0. So I need x squared minus 4 to be greater than 0. I'm going to factor that quadratic, so x minus 2, x plus 2. I'm going to choose those two zeros to be on my number line, -2, +2. And I'm going to find where it's negative and where it's positive in those intervals. I'm going to choose a number in each of those intervals. I'm going to start with numbers less than -2. So let's try -3. If I plug in -3, I get a -3 minus 2, a -3 plus 2. So I'm going to get a negative times a negative, which is positive. A number between -2 and 2, I'm going to choose 0, which is going to give me a -2 times a +2, which is a negative number. I'm going to choose a number greater than 2, so let's try 3. That's going to give me a positive number times a positive number, which is a positive number. And we are not going to include -2 and +2 because it's not greater than or equal to, it's just greater than. And we are looking for numbers that are positive because it's greater than 0. So I'm going to choose this interval and this interval. So my domain is going to be -infinity to -2 union 2 to infinity. All right, next question, number 4. Music theorist associates the fundamental frequency of a pitch F with a real number defined by P equals 69 plus 12 log base 2 of F over 440, complete parts A and B. So part A says standard concert pitch for an A is 440 cycles per second. Find the associated value of P. So I'm going to plug in 440. So P equals 69 plus 12 log base 2 of 440 over 440. And that's just going to give me 69 plus 12 log base 2 of 1. Well, log of 1, no matter what the base is going to give me 0. So I have 69 plus 0, which is going to give me exactly 69. Now, part B says an A 1 octave higher than the standard concert pitch is 880 cycles per second. Find the associated value of P. So now I'm going to plug in 880. So I have P equals 69 plus 12 log base 2 of 880 over 440. So 880 divided by 440 is 2. So I have 69 plus 12 log base 2 of 2. So log base 2 of 2 is going to give me what? 1. So I have a 69 plus 12, which is 81. Our next question is find, the amount of carbon-14 present after T years is given by the exponential equation A of T equals A naught e to the KT, where our K, our decay is negative natural log of 2 over 5,600 using carbon dating of charcoal found along with fossilized leaf fragments. Botanists arrived at an age of 36,000 years for a plant. what percent of the original carbon-14 in the charcoal was present. All right, so they don't give us A naught, they give us K, the decay, and they give us our time T. And we are trying to figure out the amount of the percentage of the original amount. All right, so I have A of 36,000 equals A naught E to the K negative natural log of 2 of 5,600 times 36,000. All right, so A naught, let's go ahead and do 36,000 divided by 5,600. So, well, I think that's rounding for me. So let's just go ahead and plug it in all together. So I have E to the negative natural log of 2 times 36,000, 1, 2, 3, divided by 5,600, 1, 2, equals 0.0116093. This is what I'm getting. So I'm going to move my decimal 2 places. So it looks like 1 point, round to the nearest tenth. So approximately 1.2%, all right, of the original amount. All right, and then the last one, explain why the limit of f of x in figure A exists and the limit as x goes to -2 of f of x in figure B does not. Okay, so let's take a look here. In figure A, if I'm taking the limit as x goes to 2 from the left, so from the left, it is going to 1, 2, it's going to 2. As I'm coming from the right, it is also going to 2. So where's from the right? I think there's probably a box here too. I can't exactly tell here. Like I think there's, why is my pencil not working? Hey Triggy, can you be patient, please? Uh-oh, my pen's not working. There we go. So I think there might be like a box like right here, but I can't see it on my paper. So from the right, it's going to 2 as well. So the limit from the left and the limit from the right are the same, then the limit exists at 2. Now, on this one, the limit from the left of -2 is -1. Man, my pencil is just not working. Well, we'll just talk through it here. So the limit here from the left is -1. The limit from the right is -1/2. So the limit from the left and the limit from the right are not the same, so the limit does not exist. So the limit from the left is -1. The limit from the right is -1/2. Therefore, the limit does not exist. I'm going to write this over here because I just feel like this doesn't make sense. So the limit in figure A as x goes to 2 of big F of x from the left equals 2. The limit as x goes to 2 from the right of f of x is 2, which tells me the limit exists as it goes to 2, which is 2. Now the limit as x goes to f of x, the little f of x, to negative 2 from the left was equal to negative 1. The limit as x goes to negative 2 from the right of f of x was negative 1/2. And that tells me the limit does not exist. And I believe that's the last one. All right. Have a good day.